Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome to chemistry class, chapter number 13. Chapter number 13, S and P block elements. Today, topics under discussions are acid-base behavior of the period TRIOXIDEs, trend in acid-base behavior, chemistry of the individual oxides, reaction of the individual oxides with water and acid. Let us discuss these topics one by one. Period 3 oxides have the formula sodium oxide with formula Na2O, magnesium with formula MgO, aluminium with Al2O3, silicon with SiO2, phosphorus with P4O10, sulfur has two oxides, SO3 and SO2. Chlorine has many oxides, but here we will discuss only two oxides, Cl2O7 and Cl2O. Now, what are their acid-base behavior of period 3 oxides? The trend is like on the left-hand sides, you have strongly basic oxides, that is sodium oxide and magnesium oxide. Then on the extreme left hand sides, you have acidic oxides. Then in the middle with aluminium oxide are the amphoteric oxides. The trend is like from strong basic oxide to amphoteric oxide and then strongly acidic oxides. Strong acid oxides are on the right hand side and strong basic oxides are on the left hand side, and aluminium oxide, that is amphoteric, is in the middle, that is Al2O3. Let us discuss these oxides one by one. First is sodium oxide Na2O. It is simply strongly basic oxide. How can you justify that? It is strongly basic oxide, as it contains oxide ion O-2. That O-2 ion has strong tendency to combine with hydrogen ions. Because they have the tendency to combine with hydrogen ions, so it is basic oxide. Then it reacts with water to gives you NaOH, and the pH of the solution becomes 14. Then it can react with HCl to produce sodium chloride and water. These 3 points, that is, it contains oxide ion, which has high tendency to combine with hydrogen ions, its reaction with water, and its reaction with acid. These 3 points are justification that sodium oxide is strongly basic oxide. Next is magnesium oxide. Again, magnesium oxide is simply basic oxide. It again contains oxide ion, but it is not as strong as sodium oxide because these oxides are not so free. What does it mean? Actually, in oxide ion, the solid is held together by attraction of +1 and -2. That is, sodium has +1 charge and oxygen has -2 charge. While in magnesium oxide, the attraction is between +2 and -2. That is magnesium +2 and oxygen -2. Now it takes lot of energy to break these oxides. So it is magnesium oxide is less exothermic than those of the sodium oxide. This is the justification that magnesium oxide is less basic than sodium oxide. Next, how will you justify that magnesium oxide is a basic oxide? First, if we put magnesium oxide in water, then you will see apparently no reaction occurs. But when you check the pH of the liquid, you will find that it is around 9. It shows that it is slightly alkaline. In fact, some magnesium oxide ions have reacted with water to produce magnesium hydroxide. This magnesium hydroxide solution, this magnesium hydroxide uh, give solution the alkaline properties. It also reacts with acid like HCl to gives you magnesium chloride, that is a salt, and water. These two properties are again showing its basic character. The next is aluminium oxide with formula Al2O3. It is amphoteric oxide. Amphoteric, what are amphoteric oxides? The oxide which has both acidic as well as basic property is regarded as the amphoteric oxides. It reacts with water, it not a simple way, but it reacts in a very different way and in a very slightly, because here the lattice is very strong and it's as it contains aluminium plus 3 and O minus 2 charge. The lattice is too strong that it cannot react with water. So the reaction is not possible. The next is it reacts with HCl to gives you AlCl3 and water. Aluminium oxide reaction with HCl show its basic nature. It shows its basic nature. The next is aluminium oxide react with NaOH in presence of water to gives you a special type of compound which are known as aluminates. These are known as aluminates. This aluminium oxide reaction with base show its acidic character. It shows its acidic character and the compound formed are known as aluminates. Aluminates are basically the compounds in which aluminium is found in its negative ion. This is possible because aluminium has the ability to form a covalent bond with oxygen, and aluminates have the formula NaAlOH4. Aluminates chemical name is sodium tetrahydroxoaluminate and it is produced with hot concentrated sodium hydroxide solution, aluminium oxide, and in presence of water it gives you aluminates. Next are phosphorus oxide, that is P4O6 and P4O10. Simply, unionized acid has formula H3PO3 like this. Phosphorus react with water violently, even with cold water, and it gives you acid H3PO4, which is known as the phosphoric acid. It is also known as the orthophosphoric acid. It, as it produces acid, so it can react with base to gives you compounds like NaH2PO4. Again, it gives you Na2HPO4, and in the last it's Na3PO4. It means that all these three hydrogen of the acids, these three hydrogen present in the acids can be replaced one by one. First one acid is improved and the product is NaH2PO4. Second hydrogen is removed and the formula is Na2HPO4, and in the last step all the three hydrogens are removed with the formula Na3PO4. The direct reaction between P4O10 and NaOH is also possible, and the products are the same. Either it reacts with acid or direct reaction. The next are sulfur oxides. Common sulfur oxides are SO2 and SO3. SO2 is regarded as sulfur dioxide. It is fairly soluble in water and it gives a solution known as sulfurous acid with the formula H2SO3, and a formula reaction is SO2 plus H2O gives you H2SO3. It reacts with base to give you a compound Na2SO3. That Na2SO3 is regarded as sodium hydrogen sulfide. NaHSO3 and Na2SO3 is sodium sulfite. In the first step, sodium sulfite is produced. It is followed by formation of sodium hydrogen sulfide. SO2 also react with calcium oxide to gives you CaSO3, that is calcium sulfite. Next is sulfur trioxide, that is SO3. SO3, it is SO3 reacts violently with water to produce H2SO4, that is sulfuric acid. This reaction is so highly exothermic that these H2SO4 produced, sulfuric acid produced, is converted into the fog droplets. It is converted into the fog of concentrated sulfuric acid droplet. This reaction is highly exothermic. The next is, this oxide is acidic oxide. You have to justify it by reacting with water and reaction with NaOH. It reacts with base like NaOH and gives you Na2SO4, that is sodium sulfate. In the similar way, it reacts with calcium oxide and SO3 to gives you calcium sulfate. The next is chlorine oxides. Chlorine has several oxides, but here we will discuss chlorine 7 oxide, that is Cl2O7, is known as dichlorine heptoxide, or chlorine 1 oxide, that is Cl2O, also known as dichlorine monoxide. Chlorine 7 oxide. In this oxide, chlorine is in its maximum oxidation state of +7. Chlorine is in its maximum oxidation state of +7, and it is the stronger acid known. Reaction with water, it reacts with water to gives you a strong acid, that is chloric acid, which is also known as perchloric acid, and it has the formula HClO4. As it is acidic oxide, it reacts with base to gives you NaClO4, which is known as sodium chlorate. These two reactions are justification that chlorine oxides are acidic oxides. Next is chlorine 1 oxide. Chlorine 1 oxide is less acidic as compared to its previous oxide. It reacts with water to give you an acid known as chloric acid with formula HOCl, and it is also known as hypochlorous acid. It reacts, as it is acidic oxide, it reacts with base to gives you sodium chlorate with formula NaOCl, which is also then it reacts with direct reaction is also possible, and it also gives you the same product NaOCl, that is sodium chlorate, and sodium hypochlorite is also given its name. These are the oxides of period 3 element which have been discussed. I hope so you got the point. Now here is an assessment for you, and these are only some questions that have been picked from your lecture. You have to read this very deeply and create your own short questions and raise your own answers. Assignment for you from my side is magnesium oxide is not strongly basic as an A to as sodium oxide. Comment on it. Magnesium oxide is simple basic oxide. Justify the statement. Aluminium oxide is amphoteric oxide. Prove the statement. Define aluminates, how they are produced. You have to give the reaction. How perchloric acid is produced from chlorine oxide. Give reactions. Also, another form of question from this topic is completion of the reactions. These here some reactions are given for completion. I hope you do this assignment and submit me on time. Thank you and have a nice day.